Hello and welcome back to chapter 2, tutorial 5. Now we're getting into very deep stuff. We're going to talk about pixel and vertex shaders. It's essential. As you saw in my last tutorials, when I tried to render my triangle, I crashed my video card because there's no shader bound to it and there's other stuff also not bound to it. So basically the program just went like crazy. So before we go any further, we need to create a vertex buffer in a pixel shader basically. So we're going to do that right now. So you can right click there, add a new item. And you're going to go in utility and select a text file. And you're going to call it triangle vertex shader.hlsl. Right? So this is the language in which the shader is used. So we're not just learning C++ here, we're also learning a new language called HLSL. So this is basically the DirectX shading language. If you were doing OpenGL, it will be called GLSL, and there's an alternative to both, which is called CG, and it's going to work on both. This is NVIDIA technology. So let's create that new file. You see it got created there. And let's create also a pixel shader. So same thing, you're going to go utility text file and you're going to create triangle pixel shader.hlsl. All right, let's add this. So now you got your two files. I'm going to put vertex first because that's what comes first. Now we need to do more setup to it. So you're going to right click on it and go property. All right. And you're going to basically go into the compiler settings, and there's the shader type here. So what you want, you want to specify that this one is a vertex shader indeed. All right, and you want to select the pixel shader, and you want to specify that this is a pixel shader. All right, this is important because they're compiled slightly differently. They have different function calls and stuff. So it's important to know which one is which. So basically if I compile that now, it's not going to work. Okay, there's no entry point. So this is just like our main function there. Right, let's get rid of a bunch of things here that we don't need anymore. We don't need the window anymore. All right. So, we have a main function there, which is called a winMain. Well, it's the same thing here. So you want to specify the main. And actually, you are in the properties here. You can see your entry point. You can actually change the name if you want. You want to call it shader main or whatever. You can change it. Let's keep it to main because it actually makes sense. All right. So first of all, so basically it's going to be a function main in there, but it's not going to be void. So we want to return actually the vertex, right? So we're going to receive the input vertex. Right, and we're going to output the result, right? We're going to modify the vertex and output a result to, and that will then get passed to the pixel shader. Okay, so let's define those searcher first because input and output, that doesn't exist. Okay, I just invented this. So let's define this. So we already know how to create a struct. The language is very similar to C++, but you will see small difference there. So remember what we were sending as input there in our triangle, right? We were sending to position and RGB. So we want the same thing. So we want float 2, all right? So it's basically an array of two floats and a position. And then we need to, this is the name we give it, can be pose, can be position, doesn't matter. But then after that, you need to do colon, and then you need to specify in capital letter position. So this part is actually important because the video card, it's an int to the video card to tell him how to treat that data. So it can actually perform some optimization on it if it wants to. In the case of position, it's not going to optimize, but in the case of our float 3 color, sometimes the video card settings can be set lower and you can have lower color quality and stuff, and the video card might actually process stuff there, and it's up to it, right? But that's why you actually int it. It's not just plain floats and you do whatever you want with them. So that's what we receive. Okay, that's the input, and then we need to define what's going to output there. All right, we're going to output similar things, but for the position, it's going to be 4 position. All right, so yeah, so this is important. It needs a full 4 position. So X, Y, Z, and W. W is usually 1, and then SV underscore position. So this is something that it's going to understand. This is the main thing in your vertex shader. It's going to know how to project that on the screen and then how to clip it with the screen boundary and all. So we need to output the final position on the screen in this format. And then the color, we're just going to pass the color the same thing as we got as input, basically. All right, so this is our input structure that's coming directly from our triangle here. And this output structure, this is something video card will understand. And also we have to end the video card because the way it will interpolate those things between the vertices, right? So our first point was down here. Our second point was up here. So for each pixels in between it, it's going to, we're only going to receive this function 3 times. But it's going to interpolate after that between the 2 values you pass there. So it's going to interpolate the color. And again, you int the video card. Well, it's a color because the video card can then do crappy gradient, to optimize and stuff like that. So it can interpolate the way it wants out of our control. All right, so let's create our output, and then we will return it at the end. All right, and let's fill its stuff. So basically its position, it's going to be the position, but we just passed 2. So we're going to create a new float 4. All right, and we're going to pass the input.position.x, input.position.y, okay, because that's what we have. We have 2. And then for the 2 next parameter, the Z and the W, you want to put 0 and 1. Okay, it's kind of important to have 1 here. So that's how we're going to pass our position. And for our color, we're simply going to pass our color and we don't care about it. So if I try to compile that now, let's right click on it and compile. See, it's actually worked now. And it put the result file here. It created a file and it did put it under debug actually. So I don't want it there. I want it directly into my tutorial folders because that's where all my files are. So let's change that. So this is going to be in where is this? Output file. All right, output files here. So see, it's actually putting it in the output directory, which is going to be debug in this case, and this is going to be complicated. So let's just change that for project there, project directory. Right, so if I compile that again, it's going to put it directly into my project folder, and it's going to be easier for me to load it after, because we need to load those result file from code. So it's a CSO. So I can go show you actually where it is. Open containing folder here. And you can see this is my project folder. All right, I've got all my CPP file were created there, and I have my shader files, and then the compile version is actually there. So this is what we want to load and put into C++. Right. So if I open that, I'm not going to open it, but it's just binary. Like there's no understandable code in there. Right, so that's how we create a vertex shader. It's actually not too far from C++, but you'll see that it's a little bit different with those types. Think of those like in C#. You have like vector4, vector3, those that knows XNA or Unity 3D. You're actually very familiar with those types. So think of them like this, but they're actually native type. And here I'm just creating a new one without the new keyword here. All right, so you can do for loops in there and more complicated stuff, and you can like in real time move the position, so you can kind of do like ocean and waves and stuff directly into your shader without having to actually. So that's very powerful because this shader actually sits in the video memory, and you don't have to transfer things from the CPU all the time. So that's why we do shaders. All right, so that's the vertex shader. It compiles, it works perfectly. Now let's write our pixel shader. So similar thing, I'm going to go here, I'm going to go in output, I'm going to change this to project directory. All right, and now remember the input we were receiving, which is actually the output of this one. So we were outputting something. So now we want this guy as the input. All right, pretty straightforward. And what the main function returns, it's a float 4, right? So it's a color, RGBA, right? Red, blue, green, and red, green, blue, and alpha, I mean. So that's basically what you return from the pixel shader. So if you want, you can just return red all the time, and everything you render is going to be red. So in our case, we're going to output the color that we passed here. Right. So what we receive from this is the is the input that we got from the output of the other one. So this and this basically have to match. And then there's a little weird syntax you have to do here: colon SV target before actually going into the function. So this basically tells you it's going to go on the render target, I guess, something, because you can have multiple target, right? You can have like 4 of them if you do different rendering. I'm going to stop talking there because that's going to go to be more complex. Maybe in the future we'll talk about this. All right. So what we want to return is a float for RGBA. So as I said, you can just return red if you want, like RGBA, right? That would be right. But what we want our color there. So input.color.red, all right, input.color.green, input.color.blue, and for alpha we're just going to put 1. Right, so that's it for our pixel shader. It's very, very small code. We just get something in input and we return it straight pipe. Right, so it's very efficient code actually. And we outputted a pixel shader.cso into the folder that we saw here. Right, so we have a pixel shader now, and let's sort them by types. So we have the compile version, and those are the 2 files that we're going to load into our triangle. All right, so let's go in our triangle now, and we're going to create 2 more member here. All right, so interface Direct3D11 vertex shader. All right, let's call it vertex shader. Initialize it to null. Hi Direct3D11 pixel shader. Pixel shader initialize to null. All right, so now we're going to load them into this. We're also going to split this a little bit. So here this is the constructor, and like we have to add the loading of the pixel shader there in the vertex shader. So we're going to create 2 new functions for this to make things a little bit more clear. All right, so void create mesh, and let's pass our renderer there. And the other one is create shaders. And let's implement those things. All right, so create mesh is what we did here. So let's just move that there, just to make things clean again. That's a good practice to take. And then we're going to basically create shaders. So in the constructor now, it's more clean. We're doing 2 steps. All right, so progress. Oh, something, I'm just going to do a parenthesis here and do something I forgot to do in the previous tutorial. It's very important. If you destroy your triangle, this guy is not going to get destroyed. Remember again, we need to clear the memory. We saw tutorials on this, so let's add a destructor here. Remember, the destructor is called when the class is getting destruct. and you want to call your vertex buffer here that you created. You want to call release on it. And since we already know we're going to use those two, we want to do that with them also. Just so things get cleared correctly when we delete the triangle, right? So because we might have multiple instances of triangle, and this can be probably maybe it's a fireball that you cast, and you cast multiple of them, and then they get destroyed, and just forget to like release the resources when you're done with it. All right, let's create our shaders now. So this is actually very simple. Okay, so the hard part of this tutorial was writing this code, which is a new language. Here we just need to load the file and pass it to our device. All right, so we're going to see something new here, basically how to load a file. C++11, no, C++ way, basically. So we're going to need to include two new things there. Fstream. All right, so remember we saw the streams. You know, we could stream into a string, we could stream into the screen. Now we want to stream from a file to a buffer, like a vector of buffer. So F for file and stream. Really simple. We will need a vector also that we already saw. And we're going to use our standard namespace. All right, so now how do you load that file? Well, you declare fstream. Let's call it the vertex shader file. So if is for input file, okay? So if it was an output stream, it will be OF stream. This is going to be our vertex shader file, and we can construct it. Let's specify the file name, which is vertexshader.cso. Remember, this is the file that got created there, right? So you saw that I actually had to right click and compile. You don't have to do this. It's going to be compiled every time you run the compiler. See, it's compiling if there was a change. All right, so you want to load this file, and you want to specify that it's going to be binary. All right, so this is just another namespace, and there's a binary, basically kind of enum inside. So you load the file and you specify its binary. You want to do the same thing with the vertex, the pixel shader file. All right, so we have two files open right now, and now we need to actually load the data from it. All right, so we're going to have a vector of char. So that char is basically byte data. It's like the 8-bit integer, right? So it's the smallest data you can use. So we just want to load data, raw data from the files. So let's call it vertex shader data. And you're just going to say basically input stream buffer iterator of char vertex file, and the same thing again. And the second one is empty. Okay, you don't pass the file in. All right, so what is that? So basically this is what it's going to do. It's going to create an iterator that's going to iterate through all the files byte by byte, and it's going to add byte by byte to your vector. All right, so this is actually a pretty slow way of doing it. All right, so later on I might do a tutorial about how to actually load a file more efficiently. But I didn't want to get into like, if I did it more efficiently, like it would have taken more than 2 lines of code. This is 2 lines of code to load a file. All right, so I want to spare you tons of line of code and more explanation. So I'm not going to go in details there, but you just write that, and it's going to basically take everything that's in the file that you just opened here and put it into that vector. All right, so remember that vectors can hold huge amount of data. So if you had to put a breakpoint there, for example, right, you will see that this actually has 15,000 bytes inside. See, I can scroll like this down to 15,000 bytes. So you can see all the bytes in the file right now. And you can actually make up some words in there, I think. So yeah, so that's how you load a file in 2 lines of code in C++. Okay, so now that's done. Now we need to actually create our vertex shader with DirectX. So renderer.getDevice, remember device to create resource. Okay, create vertex shader, and the first parameter is literally just the data. So we add our data there that we created, the vector. So just go get the data, the raw data from it, and then they want to know how big that is. So we can go get the size of that vector. And the next parameter, you're just going to ignore it. And the last parameter is our vertex shader. Okay, plain simple. You pass the data and it will create your vertex and pixel shader. So same thing here, create pixel shader and pixel shader here. And here you want your PS data. Alright, so that's all. You load vertex and pixel shader and you create them in DirectX. It's actually pretty easy. Alright, so now we're going to modify a little bit our draw call so we don't crash the video memory, the driver, I mean. Alright, so remember that we bind our vertex buffer. Well, you can also bind our triangle shaders. Right, so renderer, let's get our device context because we want to bind the resource. And remember what I said about the stage, vertex shader. Okay, set shader. And you want to set your vertex shader there. And you can ignore the 2 other parameters, null pointer and 0. Oh, vertex buffer. It's vertex shader. See, it was red. It's actually very, very nice. And same thing for pixel shader, except here instead of VS, it's going to be PS. And you're going to pass your pixel shader. And I'm going to compile this, and it compiles. And I'm going to run this and pray it doesn't crash my video card again, because we're not done. It's not going to display it. Alright, so it doesn't crash the drivers anymore. So there's actually proper vertex and pixel shader bound to the device. We still don't see anything. We still have some more stuff to bind, to set up, which is going to be the last tutorials after this one. So you can close this. So next we're going to see, basically you need one more link to link your buffer with your shader, because right now your shader will not understand the data you passed here. I know it's silly because I think it's pretty clear what we passed it, but that's how it works. And then just setting up the viewport finally to actually see the stuff. Whew, a lot of work, huh? All right, so let's see you in the last and final tutorial of the chapter 2. Thanks for watching.